Alright, alright guys, Leet code, we will do this Leet code contest now virtually. Let's take this for bi-weekly virtual. Okay, then start this contest. Right. So this was easy problem, then we have two medium and one hard problem, right? So you are given an integer array nums of odd length n. Okay. Return true if the middle element of nums appear exactly once in the array, otherwise return false. Okay. Whatever the middle element is in the array, so is it appearing once or so odd length array, it will be like this. We have to check if this element is appearing exactly once or more than one. Okay, so what we can do, guys, like 1 2 2 2 is false here. Okay, so I think let's just see this example, right? So it's not showing if it is sorted or not, right? It is not given. So if it was sorted, then it will be very easy, but it's not sorted. So what we can do? First, we can find the middle element, right? Int mid is equal to whatever the size is. Let's say it n is nums dot size, right? Int mid will be like this, n by 2, right? Then whatever we are seeing, like what are the element, okay? Then mid is equal to, okay, so element is equal to nums of mid, right? This is the element. Now guys, as you can see, let's say here 1 2 3 and 1 2 2, right? What we can do, we have 1 whatever 1 2 3 and 1 2 2. Okay, so 0 0 1, right? Or we can say like 0 1 1 0 1 1. This is like that. If we do AND operation, AND or XOR, XOR with this, right? So this XOR this is what? 0 1 XOR 1 0. This is 1 1, right? Then 1 1 XOR 1 1 0 0. Okay. Then let's do this for this 0 1 1 0 1 0 0 1 1 0 is 1 1 1 0 is 1 0. do X NOR. Okay, this is 0 0 1 1, this is 1 1. In this case 0 0 1 0, which is Okay, so this is not like this, just we can count like, okay, for int I is equal to 0, I plus plus, okay, then if nums of I is equal to element, okay, then count plus plus. If count is greater than 1, return false. Okay. Count is equal to 0 here, and we are return at the, if it is not, we return true. Let's check. Okay. True, this is false. Okay, let's try to submit it. If it is accepted or not. Okay, it's all accepted. Now we move to the next question. Okay. The question is, you are given an integer array nums of length n and integer k. Okay. A pair of indices I, k will valid if I is less than j and j is less than n. Okay. And j minus I is greater than equal to k. मतलब window size should be greater k. Okay. Return the maximum value of nums I plus nums j among all valid pairs. Okay, that's not that hard, I think. It's a fairly good question, but let's take the whole example from here, right? Try to work it out here. Okay. So here we have example. Input nums is there. We have this array 1, 3, 5, 2, 8, and k is 2. Okay. So whatever I is here, right? I is here, j is also here. We can just move j from here, right? Like, okay, so j is 2, right? Greater than equal to j, so j minus I, right? J minus I. So this is 0, 1, 2, 3, 4. So we have to move j here. J is here at least, and then we have 5 plus 1 is 6, like this, right? 6 here. Then move j from here, then we have 3, then we have 9, then move I from here to here, and remove this 5 we can get, then 11 we can get, then move here, then we can get this 18. Okay. So guys, this is the brute force. It will be like something like order of n square, right? So is there any optimized version of this algorithm? We have to find out, right? So what we need to find out is this okay. We need to find out this maximum. So if I is here and j is here, right? Now we get 6. So what we can move now? We can move j, and we can move this I also, right? So what we can do, because if I am moving only j here, right, j here, if I'm moving j here, I here, but what if I move both I here and j here? Okay, I here, j here, and again. So let's say it is here like 6 here, okay. Then I need to I is here and j is here, and my j with respect to I should be there, right? So what can I do is okay, I is 6 here and 8 is here, I is here, j is here, we got this. Then it's order of n square here, right? And we have to optimize it somehow. How can we optimize it, guys? Is there any way? Right? Sliding window, no, I think it's not how sliding window works, I think. Okay, guys, what I can do, like I am I here, right? For this I can find the maximum element, right? Which is 8. Maximum element is 8, right? Or like in this size of window, okay? So maximum element is 8. In this case, from here to here, this is order of n. And now I can find the maximum element in this area also, right? In this area. Alright. But what if it is like this? Okay. I don't think it will work because let's say it is 10 here, okay, then what? 8 and 10 should be working. 10 is there, 16, but it's going to give 18 to us. This is not how it's working, guys, right? So that's also not the case. First, let's try to do this with n square, right? Then we can look for anything else, right? Okay, so and n is nums dot size, right? And we have this two for loops, right? For int I is equal to 0 and less than n I plus plus, right? And for int j is equal to I plus k. Okay, comma j is less than n j plus plus also, right? I should be what? I is less than n minus k, right? I plus k like 0 plus 2, 0 1 2, right? Yeah, I think less than n, I plus plus n minus k is like n is like 5, which is n 5 minus 2, which is 3, 2 plus 2 is 4, correct? I think it's a good constraint, right? Then okay, and sum is equal to int min for now, and sum is equal to min or max of sum comma nums I plus nums j. Okay, at the end we have to return this sum. Just check what happens. Oh, it's 13, it's 14 now. These clarifications are good, but let's check if it gives us TLE or not. We have to optimize it or not. Yeah, it's giving us TLE. Okay, so in this case, just 3 cases are okay. I have to handle these cases. Are there any constants or not? So guys, how can we optimize this? This is a very important decision we have to take. A little bit I have to optimize this. right? Like what I will do is this is a 6 here, this is, let's say it's a 6 3 10 2 8, like this. 6, this is giving me 16, then this is giving me 8, and this is giving me 14, and this is giving me 18. So when I look this, I found this 10 is the maximum. Okay, this is maximum. From this max, okay, from this max I check, okay, if there is any element which is greater than 6 and like what is the second maximum, second max element, which is like in this k distance from this max, right? I have to find that. So is there any element from this to max, right? Okay, so I found this 16 here, okay, 16 with this, alright. Then from this, right, okay, what I can do, I will check what is greater than 6 now, right? If it is greater than 6, which is 10, for this I will found now. I will run the J, right? I will not run J for everyone. I will run only J for whatever greater than this, right? If I found for 6, then I will not run for this for 3 because it is less than this, right? Then I will just run for 10, then give me 18. Let's say yeah, I think it is let's say it's a 20 and this is 9 here, right? Then I will run for greater than 20 just, and I will not run for these. Okay, so I think this is very good explanation. Okay, so enter candidate is equal to nums 0. Okay, okay, then nums is equal to 1, and sum is nums 0 plus nums k, right, like this. And now we can go only if nums I is greater than candidate. Okay, is less than is equal to candidate, then continue. Okay, else candidate is equal to nums I. So I think I should go for this. 1 what? Output is 6 only. Okay, and this is for 13. Okay, I think it's running good. Let's try to submit this, guys. Wrong answer. Okay, this should be 14. Okay. So why I have 6 output in this? 6. Okay. Oh, I think I missed something here. I have to take the end digit. Okay, for this I have to found this okay, one for loop it should be extra here, right? For int I is equal to 0, or we can say j is equal to I plus k, j is less than n, j plus plus, okay, sum is equal to max of sum comma nums 0 plus nums j. One for loop is this, then we can connect it to it. Okay, now output is 14. Okay, expected is also 14 here, and this is 13. Let's try to submit it. Oh guys, you can see it's accepted now. Okay, we don't have to run it for everything, so that's how we can do this, submit that. And let's move to next question here. This, so minimum operations to transform a binary string. Okay, you are given two binary strings s1 and s2 of the same length n. All right, you can perform the following operation on s1 any number of times in any order. What? You are given two binary strings s1 and s2 of the same length n. Okay, you can perform the following operations on s1 any number of times in the order, like choose an index I such that s I is equal to 0 and change it to 1. Okay, so we can change 0 to 1. Choose an index I such that I is greater than or equal to 0 and minus 1. Okay, and both s I are 1. Change both characters to 1. Okay, return the minimum number of operations required to make s1 equal to s2. If it is impossible, return minus 1. Okay, so let's try some example. Very good, not very nice examples here, but okay. Let's try this. What happened? Okay, let's try this here and change this color to this. Okay, alright guys, so we have this string s1, right, is equal to 0 1 and s2 is equal to 1 0. What we can do, we at any index, what we can do, we can change 0 to 1, right? So change index 0 from 0 to 1, so s1 0 becomes 1 1, it will become 1 1. Okay, and when what I can do, change any index, right, from 1 to 1. Okay, so n minus 1 less than n minus 1, right? So what is the condition here? Condition is, guys, change indices 0 and 1 from 1 to 0. Not like this. Choose any an index I such that I should be less than n minus 1. It's not less than n, it should be less than n minus 1. And both Si and I plus 1, okay, are, change both characters, are 1, then change both characters to 0, okay. Now n minus less than n minus 1 is what? N minus 1 is 2 minus 1 is 1, less than 1 is 0. So change index 0, right? And this is I and I plus 1 are both are 1. We can change both are as to 0. This becomes 0. Okay, and we can change any index to 1 also. And so we change this to 1, then we come down 0. Now S1 is equal to S2, right? So guys, that's how we have to do this. If I can make with minimum number of operations, I can do this. If I can never do this, then right, if I can never do this, then I have to return minus 1, right? So what I can do, I think like try all the expression. I think in my mind I am coming with a recursion in this case, right? Recursion would be the best case, because let's try some like arbitrary string 101 and 100. Okay, so can we do this or not? So what I can do, this index is I is here, right? This is S1, this is S2, this is I. Now what I can do, I choose this index as I, right? And this is 1. Because this is 1, I need to check, okay, if it is this next index is also 1 or not. It is not, so I will discard this, right? Then because this is 1, now I comes here, right? And this I can change this to 1, right? 0 to 1. So I will change this to 1. So now string becomes 1 1 1. Okay. Now this is 1, right? I check, okay, this is I and this is also I, right? Okay, so this is 1 1 1, this is new string altogether, and this is right 1 1 1 0 1 already, and I becomes here, so this will discard it. We will left it to this only. This is 1 1 1. Now again one case is I start from here, right? Okay, because let's say this was 0 0 1, so how can we convert this, right? So I can start from brand new. Whenever I change 0 to 1, I have to reset this index. I have to take this I, right? So I is here, this is 1 and this is also, so 0 0 1. And one case I don't change here, I like 1 1 0. Okay, then what I can do is what I can do is I is here, this was 1 1 1, I is here, right? This is also 1, this is also 1, so this will become 1 0 0, which is equal to, now this was 0 0 1, right? This is 0, this is 0, and this is 1. Okay, and I was here, right? I have to move I from here, because so I can be here also, right? Then I can becomes 101 like this. So if I keep moving I here whenever I change something, right? If I keep moving I here like this, then it will go in for like run infinitely, right? And this is not the best case, right? So well, I can't do this like okay. So should we consider this also, right? Okay, so what I will do, I will try to end this with this, okay? And 0, 0, 1, or I can say this is the same character only, but else are different, right? These two are different. So I have to change these two characters only, okay? So this is 0, I have to change to, no, this is also same, so end is not. XOR 1, 0, 0, 0, 0, 1. So this is character is different only, baki like rest are same. So I have to change this character, which is 1. To change a 1 to 0, I need 1 here, right? I need 1 here, which is not. I can change this 1 to here like this, and this, because this is 0, and but what if I have more characters, because more characters which are different, so I don't think it's like this, okay? 101, 101, 100 like this, alright. I is here. Can I change 1 to 0? No, because this is a 0 here, so I comes here, right? Can I yes 1? So this is 1, 1, 1, 1 case, and this is 1, 0, 1, and I is here. And when I change this, where should be I? I should be here, right? Okay. I should be here, and can I change this 1, 1 here? This will become 0, 0. Okay. And this will become 1, 1, 1, and I is here. Alright, I this is discarded because I go like gone. So 0, 0, 1 is here, and I is again here. Okay. So if I keep coming back with I like this, then I will not do. Okay, I will not do this. Okay. So whenever I like this, I plus 1, I will be here. Okay. I have to move whenever I go from 0 to 1. Alright, or 1 to 0, 0. No, yeah, 1 to 0. So I have to move I here from here I to I plus 1. Okay. Alright, then I is here. 0 to 1 I can change this. 0, 1, 1. 0, 0, 1 is not there. 0, 1, 1 is there. Okay, 1, 0, 1 was already there, right? 1, 0, 1 was already there, so I will not do this. 0, 1, 1 is here, and one thing is 0, 0, 1 I is here, and this is 1, 0, 0. Okay. So I need to keep track of like if I am moving from 1 to 0 or 0 to 1. if I am moving from 1 to 0, then I have to move I plus 1 like this. If I am moving from 0 to 1, then I have to again I take the I here, right? But what if I keep coming back and it can go to infinity, right? So this should not be the case. How can I approach this, guys? You are going to issue binary string as well as same length, and okay, you can perform the following operations on any number of times in an order. So index I such that si is equal to 0. Okay. Like, can I go with like sheer brute force here? 101, 100, right? 101, 100 like this. So I is here, and it is not kind. I did not do so. I is here. Okay, 111 is there, and 1 becomes 101. I. Then I is here. So I will keep I only here. Okay. I will not move here. And this is good. Yes, 100, correct. And this is given, but let's say it was 001 like this. Can I do this? Okay. So let's try it also. So I have to try the 001. Okay, so is this same with this? No. I have to change this. Okay. I is here. I will become this 111, and this goes 101. I is here. This will be discarded. 111 is there. Is this 11? Yeah. Now from here I can choose 100. It will be there, right? I becomes 110. 11 I is here. It's not so 110, and I is again here. So 101 is there. And so 001 is there, and 101 is there, right? So what I need to do, I need okay, because it is binary string, I need to think with some bit string operations, right? Bit manipulation. Because otherwise it will not get into this, right? Right. So because this was 101, right? So can I convert from 101 to 01001? Huh? Let's check. 0 to 111 and 001 like this. I can do that. Okay. So I have to think of some bit manipulation here. What is OR operation between them, right? Bitwise OR. Okay, 101, 001. Bitwise OR is 101. What was this value? 1, 2, 4, which was 5, and this is 1. And this is gives 3. Okay. Now this is gives 5. 101, right? What about the end here? 100. This gives us 1. Okay. What is XOR here? Uh, XOR here is 1 is 0, and this is 0, and this is 1. This is 4. What is X now giving us? What is the meaning of this? XOR will tell us which is the difference, right? But what if two bits are different here? What will do? Like, okay, 1 0 1 1, and then we have 1 0 1 1 like this. Give XOR 0 1 1 0. These bits are different here, so we have to change this, right? What the bit is this? Okay, so this event we have to change to 0 to 1. Yes, so it will become 1, and this bit I have to 1 to 0. Okay, so 1 0 1 1, I have to change this to 1. So it is 0 because I can directly change it to 1 1 1 1, and this is 1 here. So what I need to do is this like is this left is 1 and this is 1? If it is 1, right? If it is 1, I will to look at left and right here. If this is left, okay, I will go what I will do 0 0 both, and I will make this 0 here and 1 here, or like keep it like this only. So it's changed, right? So I can do this, right? But what if like it was 0 and it was 1 like this? Then because this is 1, what I will do? And this is 1, then I will make it 0. So these both are 0. Now it's our same, right? It's already done, and check after that. Okay, so what I have to do, I have to XOR these strings and then find the indexes where the 1 is there, and on those indexes I have to change, like, oh, if that bit is 1 or 0 or not, right? To change this, whatever it is different, right? So I have to take the minimum number of operations also. So how can I find the minimum number of operations? Right? So I have to check all the operations first. To check all operations, I need recursion, right? So it's very complicated. Like it's becoming complicated for me, right, guys? So should I take help from Guruji for this? I think I should, right? I need some help here. So a simple greedy study does not work because a decision at one position affects its neighbors. Okay. The standard solution is dynamic programming over the string with 4 states. Okay. So dp of I, a, b be the minimum operations after processing first I positions, where a current value position I and b current value position I plus 1. Okay. After operations affecting them. Okay, so for every position we enumerate all legal operations, like one is do nothing, flip current 0 to 1. If current and next both are 1, erase them together. Okay. And transition to the next state. There are 4 possible states per position, like 0 0, 0 1, 1 to 0, and 1. Each state has only constant number of transitions, so order of n times space order of 1 rolling dp. Okay, so this is the solution it's giving us, right? And it says there is a dp of 4 vector 1 infinite. Okay. Current and next also there. Okay, it has given me the most optimal solution. Okay, give me the basic recursive solution first with explanation and simple language. So we have this 0 1 0 1. Okay, we have only 2 operations. Choose any 0 and we can come at like make that 1, and like this this 0 becomes 1 here, right? Operation 2 is possible. Choose 2 adjacent ones as like 1 1 and make them all 0. Like here, right? So we can make 0 to 1, but we cannot make 1 to 0 directly, right? To remove 1, we need another adjacent one also, right? So what should recursion do is, imagine we have s1 is 0 1 and this is, so at every step we can choose perform operation 1 somewhere and perform operation 2 somewhere, right? Each operation creates a new string, then recursively solve that new string. Okay. Flip 1, flip 0, remove 1 1. Okay. Every branch increases cost by 1. Okay, that's understandable. So base case is if current is S2, then we are done. Okay. Need 0 operations. If you already visited this string before, don't solve it again. Okay, otherwise recursive becomes infinite, right? Yeah. That's what I was saying, like I have to keep track of those strings, like if I have already visited that string or not. So recursive function solve current minimum, then infinite, flip every 0, make 1, then answer equal minimum of answer 1 plus solve new string. Okay, find every 1 0 0 again. Okay. Answer current so this is recursive code for us, guys. Okay, so we have this unordered map and string and like integer. Target we can take set also, I think, and string target is this constant infinite. Okay. To solve is current. If current is solved, return 0. If mem.count current is already there is. Okay. So what I have to return the memo of current, right? Whatever the answer is, like if it current is already there in this, okay, in the string. If int answer is infinite, okay, and n is current dot size, okay, we have I is equal to n. If current of I is equal to 0, string next is equal to current, next of I is 1, okay, the answer is equal to minimum of answer comma 1 plus solve next, okay, like we again start from 0, okay, and operation 2 is for I is equal to 0 to n minus 1 I plus plus. If current I is less than n minus 1, okay, then and current I plus 1 is also 1, I and I plus 1 both 0, and solve this again, okay, and return the memo answer. Okay, it's like simple, not hard. Then we can make it as the okay, let's try to solve this here. We have this, we should have a function, right? A function which will take a string s1, right, a string s2, okay, which is a target. Then if s1 is equal to s2, okay, return 0 in that case, and we will have a int answer equal to int max, right, because we have to find the min, right, int max here, and int n is s1 dot size, right. What we will do, we try a for loop here. Oh, also we have an unordered map also, right, where this unordered map should be, guys, where it should be, like here or here, right, it should be accessible from everywhere, right. So or the map of string comma int map here, okay, like this. If map dot count of this s1 is there already, right, then we will return s1 dot count, map dot s1, like this. I've written this, if it is already there, now that string is already there. Else what I will do, for int I equal to 0, I less than n, I plus plus, okay, if s1 of I is equal to 0, right, in that case string s is equal to s1 and s of I is equal to, I am changing to 1, right, like this, okay. And if it is like this, then I will do answer is equal to minimum of Okay, answer comma 1 plus f of s comma s2. Okay, like this. This is one case, and again case 2 for is equal to, like I can take it plus j is equal to 0, j is less than n minus 1, j plus. Okay, if s1 of j is equal to 1, right, and s1 of j plus 1 also is equal to 1. So in that case, I will have a string s equal to s1. Okay, and what I can do, and what I can do is s of I is equal to 0. No, it's a j, but okay. S of j plus 1 is equal to 0, like this. This is j, guys, right? And after that, I will return answer is equal to, for answer comma 1 plus f of s comma s2, right? Where should I enter this string, new string in the map? After the processing or before processing? Okay, current is okay, all right, then is equal to 0, string is there. Okay, then we are providing that 1. After all of this processing of this return this current is equal to answer. Okay, like this. All right. Okay, let's try this also. At the end of everything, return map of s1 is equal to answer. Here what I can return, return f of s1 comma s2. Let's try if it is working fine or not. Okay, so this is integer type, right? Okay, output is 1 1 to 0 0. It's in this case 0 1 to s2. Oh, it's a very big number. I don't know. 1 to 0, it's also very big number. Okay, like it's not considering minus 1 in any case. Let's check it here if it is considered minus 1 or not, right? Okay, so like I have to return this, right? Okay, right, like this. Okay, so into const max is equal to 49. So instead of into max